Hello and welcome to Lecture 6 in Introduction to Computational Literary Analysis. Today we're going to look at the NLTK, or the Natural Language Processing Toolkit. Let's get started. All right. So the NLTK is short for the Natural Language Toolkit, and it's the oldest and probably the most feature-rich of the Python natural language processing toolkits. It's been around for a long time, so there's a whole lot of documentation that surrounds it. Some of that documentation, for example, is the NLTK book. So if you were to go to this page, which is nltk.org/book, this is actually a pretty great introduction to programming and to doing natural language processing in its own right. It's pretty easy to understand, and there are some really great exercises. So if you're looking for extra help at all, at the bottom of these chapters, there are these exercises that will give you some extra practice. All right, so let's explore it a little bit in a Jupyter notebook. So I'm just opening a new notebook here using Jupyter Lab. I'm going to do all the same sort of stuff I normally do. I'm going to rename this. And I'm going to make an annotation here at the top. Okay, so the NLTK is a Python library, and so what that means is it's a collection of code that is not typically bundled with Python, although since we're using Anaconda in this course, it is, and we could take advantage of that. But ordinarily you would have to download this separately or use a package manager like pip to download the package so that we can use it. But thankfully for us, we can just type import NLTK, and because the NLTK is included in Anaconda, this should just work without any trouble. If this doesn't work for you for some reason, you might have to download the NLTK separately. And the command for that is usually not a command that you would run in Python, but a command that you would run on your command line. And it would be something like pip or pip3 install NLTK. And it would look like that when you ran it. Okay, so I'm going to switch this to Markdown because I shouldn't have actually run this. Alright, so one of the first things that we're going to do is just to look around and see what it is that we can do. So I'm going to use the magic command dir to have it show us all the things that are included in NLTK. As you can see, there is a ton of stuff. A lot of this is pretty technical, but some of it we're going to get into today. One of the things that we're going to mess around with is this thing called text. So text is this object, and when I say object, I mean it's an object in the sense that a string or an integer is an object. So objects are these things in Python and in other computer languages where an object it can store data, and it can also allow you to run any number of methods that are specific to that data. So you can think of it like a container, for data with a whole bunch of buttons on it. So text is one of these containers, and it's kind of like the string method, only it's much more sophisticated and can do a whole lot more. So we can access it by using this dot syntax here, which says NLTK.text. It says get the text object out of the NLTK library. Now, if I were to just run that on its own, it doesn't really do very much. But I could either run the help command, and I could get a description of this text object, or again I could press Control I to get the contextual help, and then just drag this down here somewhere. Okay, so the NLTK text object has lots of cool stuff that we can do with the text. But first, let's try to make one so that we could see what that means. Okay, it says first it's a wrapper around a sequence of simple tokens, which is intended to support initial exploration of texts. Alright, so what this means is before we can use the text object, we have to first get a text, and we have to break it up into what are called tokens. So as an aside, I should talk a little bit about text, tokens, words, stems, and limits. Okay, so in natural language processing and in computational literary analysis, the concept of a word is a pretty slippery concept. And I say slippery because we are constantly making decisions about what we should include or not include as a word, right? So if we have something like parenthesis diamond, something that just looks like this, do we consider this a word, or do we consider the parenthesis here a different word and this a different word altogether? You know, similarly, I'll annotate this. Similarly, you know, if we have something like can't, you think about that, it's a contraction, so it's kind of two words in a sense. Right? It's can and not smushed together. So is can't its own word, or is it two words? And if we break it up into two words, is the first word ka and the second word n apostrophe t? You know, these are tricky questions. So the way we get around this is we define a new category, and we're going to call it tokens. And yeah, so tokens are just a unit that is word-like. And it's an individual instance of one of these word-like units. In contrast to a token, we have something called types. Now, types are the abstract form of that word insofar as a token is an instance of a type. So, yeah, I could call this an instance of a word-like unit. A word-like unit is a type. All right, so let's take an example sentence from Porky Pig, right? So Porky Pig says, the, that's all, folks. So in this example sentence, each one of these things is a token. So tokens here, we can represent this as a list if we want. We could say the 1, 2, 3, 4, 5, 6. That's so now usually a tokenizer would break this up into two things. So you would have that, and then you would have the apostrophe S on its own as a different token. You would also have the exclamation mark on a different token. However, types is the set of all of these. So for types, we would only have the, that, the apostrophe S, the all, folks, and the exclamation mark, because we're not counting all of the times that the appears. However, if it appeared in a different form, we would count it twice. So that's tokens and types. Now there are a couple more of these, a couple more ways of thinking about things. So stems and lemmas. Actually, we're going to get to this in a second. So I'll first go over some tokenization before getting to the stems and lemmas. Because we don't want to get too off track, we are still talking about this NLTK text object. Alright, so we first have to get a simple string of tokens and then feed it to a text object. So first I'm going to do the same thing that I did yesterday, and I'm going to open up my file, my Moonstone file, which is in readings, content, and index dot, no, it's not that, text, and then moonstone.md. What I just did there, by the way, is I just pressed tab, because I know that it's somewhere in this path, and if I press tab, it gives me some options of how to complete that. Okay, so I'm going to open that and read it and assign it to a variable just called Moonstone. Now, as always, I want to make sure that I'm dealing with the right thing, so I can peek at the first 400 characters or so of it. And that looks like the Moonstone to me. Maybe I could print it to make it look a little bit nicer. Great. Alright, so this is what we want. I can split this into parts so that I'm only dealing with a smaller chunk of this if I want. So I could say split by a double pound sign, and we're going to call this Moonstone parts. So Moonstone parts which one was that? Okay, so this is the prologue. Moonstone parts 5. Okay, so this is Betteridge's narrative. Where does Betteridge's narrative end? So he has a number of chapters. It's beyond this. Okay, yeah, so it's right there that Miss Clack's narrative starts at 30. So we want everything up into, but not including 30, starts at about 5. Okay, so I just had it print out everything, which is why it took a really long time. But yeah, so I think we can make this even better and say we're taking part 6 all the way to 30. Yeah, if we want, we can double index this and say, show me the last 150 characters of that. So I can call this Betteridge because this is Betteridge's narrative. And then maybe print out the last 150 characters of that. It's printing out everything here for some reason. So, what does the very last one look like? So it's right before that. So we want to adjust this slightly. Great. And that's the last of Betteridge's narrative, the end of the first period. Okay, great. So what I'm doing here is demonstrating really that when we're doing text analysis, we must know a lot about the text that we're analyzing. If we don't do these checks, chances are we could get results that are very, very different from what we expect just because the text is different. But here we have Betteridge's narrative in this nice, neat little text file. However, you'll recall that it's split up according to chapter. So here I'm going to take the len of it just to see how many parts this is. This is 23 parts. So maybe I can rename this like Betteridge chapters, and then maybe I can make another one called Betteridge and have this one join together everything with, let's join it together with new line, so \n. Great, now let me verify the length. Great, so 431,024 characters in Betteridge's narrative. Great, and we're looking down here too, and we're seeing that that is the beginning of Betteridge's narrative, which is great. Okay, so if we wanted to, we could split this like we've done before, just on white space. And this will give us kind of like an approximate word list. And there are about 78,000 of these words. And again, I say words here, but I really mean tokens. So why don't we look at the first 100 or so words? So you see some of these contain punctuation. So if we were to count this, if we were to say, hey, count all instances of Robinson Crusoe, it would count Robinson as one, but it would count Robinson with a star in front of it as a different one. And in case there was a lowercase version, it would count all three of these as different versions of the same thing. So I'll annotate this by saying we want to avoid double counting word forms like Robinson, Robinson, Robinson. Okay, so how do we get around that, and how do we work out the problem of maybe removing punctuation? So sometimes we want to remove punctuation, and sometimes we don't. Sometimes we're interested in what punctuation is doing in the text, and sometimes not so much. So there are a number of ways that we could do that. We could go through the whole text and replace everything. I could write a for loop to get rid of all of the punctuation. But yeah, let's do this the NLTK way, because the NLTK provides this functionality for us, and it sort of does a lot of this work for us. So NLTK has a tokenizer, and if I were to look at a directory of the NLTK, one of the things that I might find is something called word tokenize. So yeah, if I just run it without doing anything else, it says it's a function. It says that it's guessing that the language is English already. And I can get more information down here too by looking at this contextual help. So it says it returns a tokenized copy of text using the NLTK's recommended word tokenizer. So yeah, why don't we play around with it a little bit? So By the way, if you were to run this command and you get an error, it could be because the tokenizer hasn't yet been downloaded. So I'll show you what that means in a second. But first, let's tokenize a sentence. So the quick brown fox jumped over the lazy dogs is a typical example sentence. If I run NLTK's word tokenize on this, let's see what it says. Resource punct not found. Please use the NLTK downloader to obtain the resource. Okay, yeah, so the NLTK, for it to work, it needs a certain amount of data, right? So it needs information about how the English language works in order to be able to figure out how to divide a string into tokens. Okay, so before we run this, we want to run the NLTK download command. And it tells us here all of the things that the download command can do. But one thing that we would want to download is punct here. At minimum, we want to run nltk.download and then give it punct. This will download everything into a folder that it just kind of guesses that you want to keep the NLTK data in. Great, and that worked out. However, I could do this differently, and I would suggest you do this. If you get a collection of stuff to download called book, this will get you a lot of other data that the NLTK needs, and we'll be using this stuff later, so we might as well just download everything in the book collection. So yeah, it's getting us a lot of corpora to play around with, which is really nice. So yeah, if you wanted to mess around with some test texts, I'll show you later how you can do that. It's downloading a whole bunch of stuff. Is it done? I can't tell. Let's try running word tokenize again. Yeah, this is a good opportunity to talk about this. So you may have noticed a scenario like this where you run something that shouldn't take a very long time, but you see this little star here which indicates that your code is still running. Chances are this means that it's hung up somewhere, that elsewhere there's something else running, and it's preventing this from running because it can only run one thing at a time. Okay, so now it finished and it executed the next cell after. Okay, yeah, so let's look at what it did. It just turned everything into a list of words, basically, and it considers that period at the end to be a token of its own. Okay, so this is what we want. We want to often be able to break up the moonstone into a list of individual words. So let's start with betteridge. Yeah, and again there I typed part of this variable and I pressed tab, and it gives me like an autocomplete here where in case I forgot how I spelled a variable, I can just press enter and it auto-completes it for me. It's kind of a neat feature of JupyterLab. Alright, so I have this betteridge text, and it says it's a string, but I want to turn this into a list of tokens. So I can do NLTK word underscore tokenize and run it on betteridge, which is the string. I'm going to call this something like betteridge words. Now I like to inspect everything. So Betteridge words, let's take the length of that. And it says we're dealing with about 94,000 words. So if we compare that to what we did up here we split this, and then we took the length of it, and it says it's about 78,000 words. Here we've tokenized it, and it says we're dealing with about 94,000 words. So this is because it's treating punctuation as its own word. It's treating lots of things as its own word. Okay, so I've successfully tokenized this. Now I can bring it into an NLTK text object if I want. I could say NLTK text, and then you see it takes as a parameter tokens, and you can also give it a name if you want. So I can give this Betteridge words, and I might as well give it a name. I could call it Betteridge's narrative. You may have already noticed this happening, by the way. If you want to include an apostrophe in something, you have to surround it with double quotes and not single quotes. Otherwise, it doesn't really matter whether you use double quotes or single quotes. And I can call this Betteridge text if I want to. Now, let's look at all of the things that you can do with a text. So if I run, again, the dir command on this, it tells me a whole bunch of stuff with underscores, but it says I can do collocations, it says I can do a concordance, it says I can do, I can count a certain token, I can do a dispersion plot, I can calculate the readability, I can get the list of tokens out of it. I can find all particular token, and I can even do this fun thing, which is to generate text that's kind of like it. Alright, so let's mess around with it. So Betteridge text, why don't we first try a concordance. So a concordance, it tells us down here, if you give it a word, it will show you how that word is used in its context. So I'm going to annotate this before I do it. So a concordance, sometimes called keywords in context, and it just shows you how a word is used in a text. So why don't we try this with a word like diamond. Now let's come down here for a second and look at all of the options that it gives us. It says that we can vary the width of the output if we want. It says we can vary the number of lines that we want as output, and we can do that in a second. But let's try to see here. This is how Betteridge uses the word diamond. Alright, great. So this is really interesting. It says it's showing 25 of a total of 154 matches, 154 times that Betteridge uses the word diamond, or someone in his narrative uses that word. So the first thing that I notice here is that it's all uppercase D, which is super interesting. So I gave it a lowercase d. If I were to give it an uppercase D, it handles this in the same way. What if I give it diamond in all caps? Same thing happens. So it's case insensitive. Another thing that you'll notice here is that it breaks up the punctuation, so it treats this as a separate entity or a separate token. So that's kind of nice. yeah, what are some other things that we could notice here? We notice it's referred to as the Indian diamond only once in this view. It's referred to as the wicked colonel's diamond, or the colonel's diamond, or the colonel's diamond here, the wicked colonel and the diamond. So that's kind of an interesting collocation. We could get the full number of matches from this if we want, just by, instead of having lines be 25 like it is by default, we're going to change this to 154. Now it gives us all of them, and we can look through and see that it's referred to as yellow diamond, plaguey diamond, Hindu diamond, Indian diamond, her diamond, lost diamond, horrible diamond. Now, will this allow us to choose more than one word? What if we were to write Indian diamond? It just says no matches. So it's only looking for one word at a time. You can, of course, write your own concordance function that that takes more than one word, and that's not too difficult to do, and we actually might do that a little bit later in this class. But this is just a quick and easy kind of out-of-the-box solution for just doing a quick search through a text for one particular word. Yeah, I'm really interested to see, by the way, I think one of the homework assignments is to get you to use this concordance function, but to try a few different words other than just diamond. So yeah, just looking through this concordance, you can already tell quite a bit about this text. It's referred to as a diamond, much less than it's referred to as the diamond. There's a lot that you can tell about this just by looking at this. But let's explore some more of the Moonstone text. Yeah, it's called Betteridge text, I think. So one is collocations. So collocations will just give us, it says right down here, collocations derived from the text ignoring stop words. In other words, what this does is, apart from stop words, which are these common words in a text, it finds words that occur next to each other often. And by default, it looks like it's showing us 20 of these words, and it's looking for bigrams. So it's looking for groups of 2 words at a time. So yeah, why don't we run this and see what it tells us. Oh, too many values to unpack, expected 2. Okay, so whenever we get an error like this, it's a good idea to just double check everything to make sure. What is collocation list? Maybe this is the one that we want instead. Yeah, okay, great. So this is a list of collocations. What does collocations itself do? Print collocations derived from the text ignoring stop words. Okay, so here's the list. It says that the word Mr. and the word Franklin occur next to each other quite a lot. It says that Miss and Rachel occurs next to each other a lot. In fact, yeah, for the most part, we have Young Lady and Shivering Sand but everything else is a character name. Came back, that's kind of interesting. Well, great, yeah, what if we were to say, to change some of these parameters? So we get the same collocation list, but we say, I still want to get 20, but I want my window size to be 3. How's that going to work? Yeah, that didn't quite work the way I expected it to. I'll have to look into this and get back to you on it. Okay, but what else can we do with this Betteridge text? So here I pressed dot, by the way, and I pressed tab, which tab just sort of engages the autocomplete function. So it tells me all of the things that I can do, all of the methods that are available for this object. So one is a dispersion plot. This is pretty cool if we can get it to work, but historically it doesn't work very well with Jupyter Lab. I wonder if we can get this to work on Diamond. Great, it works now. Yeah, so a dispersion plot, it shows you kind of what you would see by doing Control F and searching for a text, searching for a word in the text in your browser. In other words, it shows you where a word occurs in sort of the narrative time of the text. So if you see a whole bunch of lines over here, it means that it appears early in the narrative. And if you see a whole bunch of lines over here, it means the word appears a whole lot at the end of the narrative. So here Betteridge uses the word diamond a few times in the beginning, a few times here in the middle, then doesn't say the word diamond for a long time, and then does at the end. However, I wonder if this is case sensitive. What if I put capital D, diamond? Aha! See, this is a very different scenario. I can, because this is a list I'm giving it, I can give it diamond with a capital D, diamond with a lowercase d, and maybe try this diamond all uppercase. So it doesn't have the all uppercase version. I think that's just mainly in the prologue. But yeah, you have this interesting section here where he uses both forms. But for the most part, it looks like he uses the word diamond more or less uniformly. Yeah, so what other things can we try here? We can try a word like pipe and a word like Crusoe and see whether they appear together often, which I imagine they would. Okay, so Crusoe, it says it appears once, which is unusual because we read this and we know that it actually appears more than this. So maybe if we put a star next to it, maybe that's the way that we have to do it. Yeah, you see, dispersion plot is not behaving quite like it should. What if we try lowercase c? What if we try again with that star? Yeah, again because it's italicized in the original markdown. So we have Crusoe and pipe. They appear together most of the time, which of course tells us something that we already know, which is that Betteridge loves to smoke his pipe and to read Robinson Crusoe at the same time, and so this kind of collocation between these two words is telling in a way. Sometimes we want to do things that we want to search for things that we already know, to search for answers for things that we already know, so that we can begin to use these same techniques to find things that we don't necessarily already know. Okay, so I'm going to show you a couple more things in the NLTK in a sec. Great, so let's look at this text object again, look at the things that we can do with it. What does find all do? This is interesting. It says find instances of the regular expression in a text. Okay, so a regular expression is really cool because it's this thing in computer science where you can refer to forms of words, words that have multiple forms. You know, so if I wanted to find diamond with a lowercase d and diamond with an uppercase d, I could write a regular expression that looks like this. Regular expressions are kind of beyond the scope of this class. You know, they could be their own class entirely. But that did not work quite the way I thought it might. I guess they are semicolon delimited in the output. Yeah, I could also say star here. Actually, it's not star, I think it's dot. Yeah, that didn't quite work the way I thought it would either. Yeah, so regular expressions are kind of tricky to get down. We won't really get into this a whole bunch. In fact, yeah, we're not going to touch regular expressions at all, pretty much. Yeah, let's look around though, because there might be some other things that we could use. Count is kind of neat. Count the number of times this word appears in the text. So let's count diamond 7 times. Let's count diamond with a capital D 147 times. Great. What else can we do? Generate. Historically, generate has not worked that well. Maybe it's fixed so far though. So what this does is generate, it says random text generated using the trigram language model. So basically it tries to read the text and it tries to understand the probabilities that certain words follow other words, and then it tries to generate a text based on those probabilities. I can actually show you how to write an algorithm that does this. It's not terribly complex. Yeah, let's see if it works. Sometimes this doesn't work. Great. Yeah, so this is fake Betteridge here. Meant in connection with Rosanna and a kind of fellow feeling for each other by taking an oar in my room that I have of girding at each other. You see, it's fake language, right? So it's kind of gibberish, but at the same time you can kind of hear Betteridge's speech there somewhere. It's kind of cool how you can do that. As long as I did after that, when your wife closely, for instance, said that. I beg your ladyship with these particulars to show you how my father... You see, it almost sounds believable in a sense. Betteridge text dot... Why don't we try readability? Let's see if this works. It says it needs one required positional argument, which is the method. And it doesn't tell us what method we should use. Yeah, I have a feeling that, yeah, you can see from the code of the function itself that readability has not been implemented in this particular version. So that's too bad, we just can't use that one. What else can we do here? Oh yeah, so we can look for similar words, words that have similar context as others. It says it finds other words which appear in the same context as the specified word. So what if we were to try diamond? It says these are things that it thinks are similar to diamond. So moonstone, that makes sense. I think it's interesting that Indians and servants come up here as things that are similar to diamond. Betteridge text dot vocab. Yeah, so this doesn't tell us a whole lot about what it's going to do, but it seems like it's probably going to give us a frequency distribution. What happens if we run it? Yeah, so it's giving us this frequency distribution object, and this just tells us how often all of these things occur. So it says that we have 3,472 periods. We have 2,000 something instances of 2. The is the most common word that's not a comma. Yeah, so what can we do with that? Betteridge vocab. Why don't we assign this to something called Betteridge vocab? Now down here in the contextual help, it tells us that this is a frequency distribution. And let's see what kinds of methods it gives us. Well, we might have to do this where we run the help command on it. Yeah, so we can get the frequency of a certain token this way. We can get a list of words that occur only once. Here it's using samples to mean tokens. We can get the most common words. We can plot the occurrence of certain words. We can tabulate them. And we can update this with new data if we want. Yeah, what are other things? We can get the most common, however many elements we want. And we can do a lot of other things with it. So, yeah, why don't we try one of these? Let's pick one. Yeah, let's just get the frequency of diamond. So this is just scientific notation. It tells us that this is a very small number, because this is times 10 to the negative 5th power. So you can just think about this as like many zeros before this number. Yeah, so let's try diamond with a capital D, see if that's any different. Yeah, so this is a much larger number than the previous one. So what does it mean that these are very small numbers? It's because it's not a count, but it's the count divided by the total number of what it calls sample outcomes, but it means tokens. So, if we're comparing text of different sizes, we want to be able to say, okay, this text has 500 words, this text has 100 words. So the incidence of the number of times the word diamond appears in both is going to be differently weighted for each one. It's going to mean different things. So in the smaller text, if the word diamond appears a lot, it's going to be more meaningful than if it appears a lot in a much larger text, simply because you're going to have more chances for it to appear in that larger text. So we're going to do a lot of this stuff by hand, but it's kind of nice to know that the NLTK can do this for us. Hapax is cool. So hapax legomena are expressions, like words or expressions that happen only once. So none of these words repeat. Some of them because they are separated with things like dashes. So yeah, you can see that with something like this, the NLTK tokenizer is not doing a perfect job. If we were interested in counting years and generally as two separate words, it's not doing a great job at doing that here. So we would need to pre-process this text a little bit to maybe add some spaces around the dashes, add some spaces around these stars. It's it's going haywire in a couple of places and not giving us quite what we want. We might also want to lowercase everything here, if we're interested in counting things that way. Okay, so there's quite a lot. There are quite a lot of hapaxes, but there's quite a lot of other stuff that we can do with the vocab. Let's see what plot does. It plots samples from this frequency distribution, displaying the most frequent sample first. What if we just run this and not give it any arguments at all? Is it going to be crazy? It's taking a really long time. Okay, so it says if an integer parameter is supplied, stop after this many samples have been plotted. Why don't we try doing that? So why don't we try giving it a small number like 5. Great, so it shows us a plot here with some common, what it calls samples, and what I'm calling tokens. Yeah, what if we were to get it to plot 40 words? Yeah, so these are some of the common words in Betteridge's narrative. Franklin is in the top 40, which is surprising. Sergeant, that's also kind of surprising. A lot of these are just kind of very common words in the English language. But it is interesting that these two names pop up in this list. Yeah, what if we were to give this a word like diamond? Is it going to be able to plot that? Or what if we gave it a list? It doesn't like that, so it only wants us to plot a certain number of words. Yeah, so anyway, this is, I'll stop here, but this is just a taste of the kind of thing that you can do with the NLTK. The key here is just remembering that to use any of these functions, what you first have to do is import the NLTK. Then you have to tokenize, well, you have to read your text and then you have to tokenize it. Okay, so I'm tokenizing this somewhere, yeah, I'm tokenizing this down here. And then you can load it into this NLTK text object. And from there you can do all of this fun stuff that the NLTK allows you to do just right out of the box. Yeah, maybe I'll show you one last thing that you could play around with. If you look at NLTK dot, what is it, text? Okay, yeah, so here we go. You can run this command where you say import all of the test texts from this module nltk.book, and what this will do is load a copy of Moby Dick, a copy of Sense and Sensibility, a copy of the Book of Genesis, and so on, and it loads it into these variables called text1, text2, and so on. So if I look at text1 on its own, it just says that's Moby Dick. And I can do things like I can look at the vocab of Moby Dick, and I can plot the most common 40 words of that function. Aha, I was looking for where whale might appear. Yeah, so what else? I can grab the Book of Genesis, that's text 3, and I can generate some fake text that sounds like the Book of Genesis. Laid by here and said unto Cain, where art thou? And said, go on, I will not do it for 10 sons. Okay, it sounds vaguely Bible-y. You can, yeah, text 6 is the script from Monty Python and the Holy Grail. You can do a dispersion plot on a list of words like shrubbery and knee, for example. And you might find this interesting if you've seen this movie, because there are these knights that appear in the beginning of the movie and also appear at the end, and they demand a shrubbery from some other knights. So this will give you, I think, more than enough to play around with for a little while. All of this is kind of baked into the NLTK, and because we loaded the Moonstone into an NLTK text object, you can already start doing your own text analysis of just any plain text that you have around. All you would have to do is load it, tokenize it, and then load it into an NLTK text object. So we're going to save stems and lemmas for the next time around. And tomorrow we're going to explore even more of the NLTK, which was this awesome library. All right, great. See you tomorrow.